we'll invite Freddie to do the next set of slides.
My name is Freddie Künstler from Init7, and I would like to thank Michuki and the team here to give me the opportunity to talk. The topic I'm going to talk about is how to maximize the available capacity. It involves BGP traffic engineering and some best practice. My background, I'm a founder and CTO of Init7, and carrier and internet service provider based in Zurich, Switzerland. We're a privately owned company, and we run a dual stacked V4 and V6 backbone, AS number 13030, 10 gig or multiple 10 gig enabled. We're connected to some 20 internet exchanges, and we have about 1,000 BGP peers or customers. So this is the marketing slides. I'm going to skip them because I don't want you to get bored. And if you have any questions about Init7, talk to me later. The usual disclaimer slide. Yeah. I give a few examples here in this presentation, but it's your responsibility if you use them properly. Don't blame me if anything is wrong. Of course, if you find an error in the presentation, I'm happy to correct it. But don't blame me if your network breaks if you use my methods. So, and Michuki was already talking about the typical role of the peering coordinator. I have a few slides for the start taking on this topic. And first I would like to show you a typical picture of the peering coordinator. So this is how a peering coordinator usually looks like. It's, as we have this German expression, eierlegende Wollmilchsau. It means egg-laying wool milk pig. The actually word-by-word translation is from Google Translate, jack of all trades. But when I translate back jack of all trades, it doesn't get back to me with eierlegende Wollmilchsau, which this picture shows. A peering coordinator must be able to fulfill a lot of roles. I described a few of them. So first and foremost, it's a commercial aspect. A peering coordinator has to fulfill or to cover, because the CFO of the company usually gives him a very tight budget. I have two quotes to illustrate this. An Init7 customer told us a couple of months ago, I have 200 gigabit of traffic and I have 100,000 euro. So how do I put these 200 gigabits into the 100,000 euro? So if you made the math, it gives about 50 euro cent per megabit of traffic he has available to dump his traffic. It's actually a content-heavy network. And another quote is coming from Raul from Telefonica. He said, there is always more bandwidth than money. And I think we all can agree to that we have way more bandwidth. We have way more packets to deliver than we have money available to do it properly. So there's a commercial aspect, but there's also a technical aspect. BGP is the protocol to learn. You may have taken classes or did a lot of lab work, and everything works just fine, but in the real life it's a different story. I've been working with a CCIE certified person. He was hired for a customer, and he was actually working for a consulting company, and they charge quite a bit of money. But he was pretty much clueless. He fulfilled all the tests of the to pass the CCIE certification, but he wasn't able to do a proper BGP configuration for transit and peering. So I thought, this is a bit disappointing. But never mind, there are more aspects to cover of a peering coordinator. The social aspect is quite important, actually. The peering coordinator must be able and willing to travel to events and talk to prospects. And I disagree with Michuki. Sometimes the peering coordinator is also a salesperson. Because you always want to get the best deal for your company. And sometimes the best deal would be selling someone transit, because peering simply doesn't make sense. But there are social aspects also. A peering coordinator suffers quite a bit from jet lag, and I was really happy to come to Tanzania this time and not flying over to the United States, because I'm not suffering from 1 hour time shift, but 6 hours gives me always a hard time. Bad food, horrible hotels, and I'm not talking about Kunduchi here. We are away from family. I have a 2-year-old boy at home who misses me greatly, and I probably miss him even more. Then there is too much alcohol. Hello, Will. Sorry about that. I couldn't resist. Not enough sleep. And then, last but not least, unfinished work piling up on your desk at home. But it's fun to come to these events, and I greatly enjoy it. More aspects. We have a quality aspect peering coordinator has to cover, because this person is to blame if packets don't arrive properly. Business customers are yelling at you because their Citrix server farms are terribly slow in response time. Gamers are complaining because they're shot before they actually see the competition in the game. VoIP users cannot understand their user. They cannot finish their phone calls properly. Then we have video, massive bandwidth. If YouTube doesn't load fast, it sucks. And last but not least, live television, real time. If you ever have been watching a soccer game live over the top internet, then you know what I'm talking about. If the goal of the soccer game happens and you don't see it, it simply sucks. Transparency aspect. If you take decisions to peer with someone or not to peer with someone, or de-peer someone, everybody in the worldwide can see it immediately, because there are companies out there which, to name a few, it's Renesys, for instance, or Arbor Networks. They notice every setup or of any BGP relation globally. So it's very transparent what you do or what you don't do. Then also a peering coordinator gets involved into politics. So probably a local incumbent refuses to peer with a competition in country. Sometimes silly business decisions are made by the management, and you have to live with it. And this makes life of a peering coordinator hard. Future growth aspects. Traffic growth is massive. There was just recently a prediction out in the news from Cisco, which says that we're going to see 4 times more traffic by year 2015, and your budget definitely won't grow the same way. Then how do we predict the traffic growth? We don't have much information. It's probably just raw assumptions which you get by experience and looking into the past. Sometimes marketing pees you on the leg because they make a new promotion. Hot deal, all XDSL users get double bandwidth from next month. But they forgot to ask, do we actually have the backbone capacity to handle this traffic? You read this decision made by the management in the newspaper advertisement. There's also dependency. If you need to upgrade pipes, waves, collocation routers, etc., you need the capacity today, but the upgrades are delivered in 4 to 5 months, and by then you already need more capacity. So we are always lagging behind the actual bandwidth need. Then it's also a question of the remote management. If you have to have someone installing gear, let's say in the United States, then you have time zone shifts. You have to consider some technician is trying to work in a data center which is very noisy, very loud. You hardly can understand him on the phone. And then last but not least, internal company processes. Who is going to decide about upgrades? If you need to get someone's signature from the board to order a cross-connect, which costs probably a couple of $100, then it's going to be a hard life. And another aspect I wanted to cover is the unreliability aspect. Things break. So there are a lot of reasons why things break. Technical reasons, but also political reasons, business decisions, act of God. I like this term because it's not in the Swiss or in the German language too much like in the English language. And of course, always the peering coordinator is to blame. So we see fiber cuts, we see power outages, and this is not a joke. We see power outages in repeater stations. Transmission equipment goes down because billing of the electricity wasn't paid. We see dirty patch cables, we see broken hardware. I also heard histories about stolen hardware from data centers. Then political unrest, just to name a few: Egypt, Libya, Syria, just recently. Then peering spats, look in Google for cogent depeering history, and it's quite a long story, etc., etc. So, giving this all these aspects, I think you probably can understand why I choose this picture. So, I'm going to talk about managing traffic now. Managing inbound traffic is probably more relevant for you because you likely are running eyeball networks. But as a matter of fact, we have to understand outbound traffic managing first before we can manage inbound traffic. Just to remember, if you're new with BGP, the route map transit in is affecting outbound traffic and vice versa. So people sometimes do this the wrong way around, and I just want to make you aware of this. So you probably learned the BGP best path selection algorithm in some training or Cisco class or whatever. And there's 13 decision parameters following an order, and some of them are really important and some are not. So I'm going to try to explain the 4 important ones and just ignore the others. What is relevant in the best path selection algorithm? It's definitely not weight to avoid this. It's not a tool, it's a sledgehammer. And it's also proprietary by Cisco. So local pref basically is the parameter which is supposed to be used for steering outbound traffic. I have here an example, a local pref 300 for customer routes. For peering routes you use 150. For transit routes you use 50 as an example. Use it with care. It can increase latency if you prefer a peering route somewhere far away over a transit route. It can increase latency. Local origin is not really important, so we have number 4. It's shorter AS path. The shortest AS path wins. Then origin type we can skip. MED number 6 is used for distinguishing between cold potato routing and hot potato routing. We just had this from Mark in the in the in the important in the jargon, and so if